So we'll start with the vector A, which I'll draw right here. And any vector can be drawn as the hypotenuse of a right triangle where the legs of that triangle are parallel to the horizontal and vertical axes. So this side, which is parallel to the horizontal axis, is called the x component. And because it can be positive or negative, the x component can be positive or negative, I have to take the absolute value of it because the side of a triangle is, by definition, always positive. And here's the y component. And again, I have to take the absolute value of it. Now, I said you could draw this for any vector. I should be careful. You can't do this for axis vectors, but there's only 4 axis vectors, so that's not a big deal. But anything that's not an axis vector, which is the vast majority of all vectors, can be drawn in this fashion. We immediately have the Pythagorean theorem, because it's a right triangle. And notice I've done away with the absolute values, because whenever you square this number, whether it's positive or negative, you're going to get a positive. So we don't really need the absolute values anymore. So this is a basic relationship. I'm sure you're all familiar with the Pythagorean theorem, so no big deal. We also have our trig relationships. If I define this angle theta, notice that it's the angle between the vector and, in this case, our x component, but you might say the horizontal is often how it's phrased. So this is the angle between the vector and the horizontal, theta. Okay, well, so I can talk about the sine of theta. If I talk about the sine of theta, that has to be the opposite over the hypotenuse, which of course in this case, that's going to be a sub y, and it's the absolute value, over a, the hypotenuse. The magnitude of the vector is by definition always positive, so I don't need any absolute value signs there. And I could also do the same thing for cosine. Cosine is adjacent over hypotenuse. So that's going to be, the adjacent is a sub x. So there we go, absolute value over a. And one last thing we can do, we can talk about the tangent. That's the, you can do sine over cosine for tangent. You can also do, in terms of the size of a triangle, it's opposite over adjacent. So that's ay over ax, absolute value. Now these can be rearranged. I can solve this, for example, for the y component. Maybe I know the angle and I know the magnitude. So I can go a sine of theta, that's going to equal a sub y. Now notice I've removed the absolute value here. When I take the absolute value away, that means I have to put a plus or minus here. In other words, I have to choose whether the y component is positive or negative. And it would be the same thing down here when you solve for the x component. You have to choose whether it's positive or negative. And you have to look at each vector and make that decision. And that's based on which direction you've called positive and which ones you've called negative. Typically, we call up, or towards the top of the page, positive y, down is negative y, to the right is positive x, to the left is negative x. In this case, my vector is pointing up and to the left. Since it's pointing up, I would choose, if I was doing this very specific vector, I would choose the positive sign here. Because my y component has to be positive, up is positive, and it's going to the left, so I would choose the negative down here for the x component because it's going to the left is negative. The tangent, we could do a similar thing here to solve for the tangent, but that's not typically what we use the tangent for. Usually this is used to find the angle. Now you could find the angle using sine or cosine. People often use the tangent to find the angle. It doesn't matter which one you use, as long as you do it correctly. In this case, if I'm doing tangent, I would be taking the arctangent, or you might say the inverse tangent of the absolute value of ay over ax, just like that. Now I did all this for the angle theta, which is the angle relative to the horizontal. We could also do it for the angle phi, which is the angle relative to the vertical. That doesn't change the Pythagorean theorem, but it does change our trig functions. Not too much. You'll see they look very similar. If I do the sine of phi, now I'm doing opposite over, well, I'm always doing opposite over hypotenuse, but the opposite is now, it's the x component. Before it was the y component when we did theta, but with phi, the opposite is the x component. So it's a sub x, absolute value over a. And the cosine is a sub y, absolute value over a. Because now the y component is the adjacent side to that angle. And if we do the tangent, that's going to be a sub x over a sub y. Okay. And now if we do the arctangent to get that angle, it looks like that. So you can see these look all very similar to what we got down here. And of course I could rewrite these. This is a plus or minus a sine of phi, that's going to be a sub x. This is plus or minus a cosine of phi, that's a sub y. The big thing, there's several things I want to stress here. First off, again, with the components, you have to choose, if you're solving for them in this way, you have to choose whether they're positive or negative. And that's based on how the vector is drawn and which way you've called positive and negative. For the angle here, this one, phi, that's going to tell us the angle relative to the vertical. It's going to be an angle between 0 and 90. Theta, this is going to tell us the angle relative to the horizontal. And it's going to be an angle between 0 and 90. That's all there is for these relationships. You should check out the other video to see how to add two vectors.